equation is what we're looking for here. What do we got? X equals, it sure is. It sure is. Coordinates of the vertex?
1, -10.
Boom shakalaka is what we say to that. Interval where the graph is increasing, so going uphill.
Hard 1, infinity soft.
Hard 1, infinity soft, exactly. All right, starts at 1, and we can never capture infinity, so we can't put the hard bracket on that. Exactly. Decreasing.
Soft, infinity 1 hard.
Infinity 1, soft.
What's that set?
Nah, I said.
I said soft, infinity 1 hard. Soft, infinity. These are one syllable words though.
I'm just enjoying all of this. It's just so great. Just the whole interaction, like getting hung up on the name of it, like it matters.
That is a soft bracket and a hard bracket.
Yeah. Or a square bracket, a round bracket, or squiggly, parentheses, brackets, or
soft and hard.
or one of these and not one of those. Like honestly, at the end of the day, one includes the value, one doesn't. So the square one, it allows you to get to the one. The round one say that you'll never actually get there. All right, so the standard form of a quadratic, also known as a vertex form. Adios. All right, so that's the form y equals a times x minus h squared plus k. You don't even know it. How can you say you hate it? You just met it.
I thought it was like the AB one.
There is an AB one. This is different.
Yeah, it is.
That's actually the general form.
Oh.
Yeah. I had this up earlier, but it makes sense to talk about it now because people look at this and say, okay, now you're just going out of your way to make this more challenging than it needs to be. There is value to this form because within this form, you actually have the vertex. That's why another name for it is called the vertex form of a quadratic. So the h and k values are actually the vertex of the parabola. All right. So if you ever have a parabola written in this form, or you can get it into this form, then you'll automatically know what your vertex is.
Wait, why would it have 2 vertexes?
Some functions actually have more than one vertex.
Oh, so it'd be like,
Yeah.
But can't you just find the vertex just by looking at it?
Sometimes, but sometimes the numbers are hideous.
So if it's like this, then wouldn't there be 3 vertexes?
There would be 3 vertices, and that would be a 4th degree equation. So you'd be dealing with something that's raised to the 4th power.
How could you have 2 vertices though?
How could you have just 2? Let me see if I can visualize.
One. What?
Because if it were to go in the same direction, it has to be symmetrical.
Exactly.
So?
Oh yeah.
So if they start and end in the opposite directions, yeah. Right, and that's an example of a cubic model. But we get a little ahead of ourselves. This is something that is a direct consequence of completing the square, which is good because actually it depends on your perspective, I guess. But we spend so much time practicing completing the square, where it's like, well, don't you want to put it to good use? Of course you do. I don't know that you actually agree with that, but most of the time people, it's complicated. Let's put it in a rear view mirror. But I look at it the other way. I look at it. We better be learning this for a reason. It's complicated. I want to put it to use. So the axis of symmetry would be x equals whatever the h value is, and the vertex is h comma k. All right. There's other ways to do this because we also know that the axis of symmetry is x equals negative b over 2a. The issue with that is I don't see no A's, well, I see an A, but I don't see any B's in my standard form equation. You know, so this one doesn't quite fit what we're doing here. But if you're given an equation in its general form, you could use negative b over 2a instead of this approach. But I want to familiarize you with the approach to get it into standard form because there's value to it. All right? The reason why it's called standard is because it is a standard approach no matter what function you're dealing with. It could be linear, quadratic, cubic. You could throw a quartic function in there, which is a power of 4. You could get into trig functions, exponential functions, logarithmic functions, so types of functions that we're going to learn about down the line. They can all take on this form, so there is consistency. Anytime there's consistency, there's familiarity. Familiarity means less stuff to study, in my opinion. All right. So let's practice with at least a couple of problems, time permitting, and see where this takes us. All right. So axis of symmetry and the vertex. Now, looking at the question, it doesn't say to do it in any particular way, so that's always something to keep in mind. I expose you to a variety of different approaches. In this circumstance, you get to choose which one you like, and then go with that. All right. In the last unit, it was you had to learn factoring, completing the square quadratic formula, and you had to demonstrate knowledge in all three. For this topic, I'll show you both methods. Well, I'll show you one today and one tomorrow, and then you can pick which one you like more. All right. So here, I'm going to apply the completing the square technique. If I'm going to do that, and the presence of the y tends to throw things off a little bit, at least conceptually, but it's still the same idea. I'm going to get rid of the 7. I'm going to add it to both sides. So I'm looking at y plus 7 equals x squared plus 4x blank, because I need to complete the square. All right, you want to get to a point eventually, maybe you're not there yet, but you want to get to the point eventually where you're doing the completing the square part of it in your head. All right, so what is the formula for that again? B over 2 squared. So this part of it down the line should be something that calculation is happening in your mind, not necessarily on paper. But it's still Algebra 1, so let's do it out by hand, you know? All right? You're not expected to do all sorts of complicated math in your head just yet. All right, so 4 over 2 squared would be what? 4. As calculations go, that wasn't too bad anyway. All right, so left-hand side becomes y plus 11. Right-hand side, that's going to factor. What is it going to factor to? X plus 2 squared. All right, so far very similar, except for the fact that y is there, to the completing the square approach to solve for roots. Normally at this point we would take the square root, but if our goal here is to write it in standard form, the only thing I have to do at this point is get y by itself. Subtract the 11, and that's it. So y would be equal to x plus 2 squared minus 11. So from this, I can get my vertex and my axis of symmetry. They asked for the axis of symmetry first and then the vertex.
Oh,
I like getting the vertex.
Putting it into standard form.
Correct. And then from the standard form, we can state the vertex. What would the vertex be? Just look at the relationships above.
Negative 11.
That's part of it.
Negative 11.
Very close. Not positive 2. Negative 2, exactly. And this little stray mark just showed up out of nowhere. Negative 2, negative 11. All right, so just think about that for a sec.
Wait, so would we plug it into the equation?
No, we're pulling it out of the equation.
You have to memorize the standard form.
Yes.
Oh, because we have like 11 is in
That's
this,
what I'm
negative
getting, yeah.
11 is k because it's positive, it stays negative 11, but you have negative h is a positive 2, so it goes
Correct.
negative 2.
I'm going to reiterate that for
So many
everyone.
letters.
So the formula itself is x minus h. All right, so I'll just rewrite it next to it. Y equals a times x minus h squared plus k. All right, so somehow the negative h became a positive 2. In order for that to happen, negative had to become positive, which means I had to have plugged in a negative number. right? So that's where the negative is coming from, right? So in order for a negative h to become a positive 2, it must have been a negative 2 substituted in there. If you're ever really nervous about this, all you have to do is take those two parts, the positive 2 and the negative h, and set them equal to each other and solve for h. H would be equal to negative 2. You do the same thing for the k, except it's a little easier to see. If I want to make k into a negative 11, what do I do? Replace k with a negative 11.
Would h always be a negative either?
H will always be the opposite sign of whatever is on the
If we had
inside.
X minus, well, we couldn't get X minus 2, right? Because
You could if you put in a positive 2 for h. Because then it would be x
Yeah, but
minus.
through completing the square, right? You wouldn't be able to through that method.
You
right?
could, if this term is negative.
Oh yeah, I don't know what I'm thinking.
All right. So my axis of symmetry comes from the vertex. That's why I did the vertex first. So my vertex is negative 2, 11, negative 2, negative 11. What's my axis of symmetry? X equals negative 2. It's just the x value of your vertex. All right. So if your equation's in the appropriate form, you have everything you need. And I'll show you down the line how to create the graph just by knowing this equation. If you know this equation, very easy to create the graph. Time check, 7 minutes. All right. So let me do one a little beefier. This one's got a leading coefficient. But just like when we were learning about completing the square, yeah, divide by the 3. Same approach. Divide everything by the 3. Yeah, we'll get some fractions. That's fine. Calculators exist. All right, I need to vacate the 1/3, right? I need to get that out of there. So I'm going to subtract it off. That doesn't look as nice, but it's still the same situation.
Wait, since they have a common denominator, you can do y minus 1 over 3, right?
You could, but it's going to be easier if we leave it like this. All right. So I need to complete the square. So again, a b over 2 squared. What's that going to be?
9.
And 9. Add 9 to both sides. I'm going to need negative 1/3 plus 9.
Negative 28 thirds?
Close. It's the right idea. 26 thirds, yeah. And it's positive, right?
Oh.
And the right-hand side factors to what? Yep, or do.
Can we add back the 26 thirds?
Subtract it off.
Yes, yes.
The only goal at this point is just to get y alone. All right? So that's the only thing you got to keep in mind, is that my only responsibility here now is to get y by itself. And if you do that using appropriate orders of operation, then you'll be fine. So we're subtracting off the 26 thirds.
Multiply by 3.
And then after that, we'll multiply by 3. So y over 3 is equal to x minus 3 squared minus 26 thirds. And then again, as you said, we're multiplying by 3. All right, so on the left, it just becomes y, right? We're multiplying each part by 3. So the binomial gets multiplied by 3. I'll just put coefficient of 3 right in front. And what's negative 26 thirds times 3?
26.
The negative 26. My thoughts exactly. All right, and what is my vertex?
Negative 3.
3, negative 26. And my axis of symmetry?
3.
X equals 3. All right, axis of symmetry is a vertical line. Vertical lines are always in the form of x equals. All right. I don't like making trick questions on tests because they're just mean. But since the Regents is going to do it, I have to do it to prepare you for it. So you're going to take a test, and you're going to have a problem like this that asks you for the axis of symmetry. You know one of the choices is going to just say 3. Right?
Instead of X equals 3.
3. And another choice is going to say Y equals 3. And another one is going to say A equals 3. Right? So you got to know it's X equals 3. Pizza.
Is there a program in the calculator for this?
There is an approach in the calculator. It's not a program, though. But we will go over it. The issue with the calculator is that sometimes you can get bogged down on the fact that decimals are a thing, and the approach in the calculator is really good with whole numbers, but not necessarily decimals.
So since the h is negative, you just flip like whatever number.
Whatever the sign is on the inside, yeah. So you have two approaches that you could use. You could use a calculator approach, or you could use completing the square. But ultimately, we want to get the equation in standard form, and we want to determine what the axes of symmetry and vertex are. All right, so depending on the instructions, you can do it any way you want. But the harder way to do it is with completing the square, so that's the thing that you want the most practice with. All right, so what do I have to do first? Divide by -3? Yeah. So y over -3 equals x squared minus 2/3 x minus 5/3. And we have some ugly fractions here, but we have calculators too, so that shouldn't be a problem. Add the 5/3, right? Now look at this. We still got to do a b over 2 squared to get that term. So you may want to use your calculator now. So we need -2 over 3 cut in half and squared. One ninth. All right, so then I need 5/3 plus 1/9. (16/9). I also need the factored form of the trinomial. Very close. It's minus. All right, and again, just thinking in terms of technique, really it's just get y alone now. So let's bring the 16/9 to the other side. And then what? Multiply by -3. All right, so we get a clean y on the left-hand side. You better get a clean y on the left-hand side. That's the whole point. On the right-hand side, we have a -3, x minus 1/3 squared. We're going to have a plus because we have two negatives. Plus what? 16/3. All right, so from this, we can get our vertex. And our axis of symmetry. Our vertex is what? 1/3, 16/3. And our axis of symmetry, x equals 1/3. All right, so it's for this problem that you see the big drawback to the calculator, because your table doesn't go in thirds unless you tell it to. So you're not getting that nice symmetry in the y column using the calculator, right? Because it's just not going to fly. So you need another approach, right? So
how do you get the axis of symmetry to be 1/3 when it says negative?
it's always the opposite of the sign of the thing. So the question, a follow-up question would be, how can we get this information without having to resort to the calculator? Right? And that brings us to the next page. Right? And that's the other formula that we talked about. Nah, it's all right. It's all right. So anyway, number 3. We have different strategies, and they're all rooted in stuff that you know. The one that's most recent, I was going to say most familiar, but maybe you feel differently. The most recent thing that we covered was along the lines of completing the square. So that's why I started with this idea. So first move when completing the square. We always want to make sure what? You get the 3 on the other side, sure. I'll go with that. Divide by the -2. It doesn't matter.
Oh my lord.
You could add 75 to
So whether we do this first or second, it doesn't make a difference. So y over -2 minus 3/2 x squared plus 4x. And
We ultimately want to get 1 and it's O to get, right?
correct. After we do the part,
So like we do this,
That
do
cleans
something
it.
with that, then bring it back over, right?
yeah.
Yeah.
So the b over 2 squared, you don't always want to have to show the step. If it's complicated, then of course show it. But if it's something simple, then just go for it. In this case, I'm adding what? 4. And we're doing that to both sides. All right. So we're looking at y over -2.
What's 3/2?
That is a good question.
11.
Well, if it were positive 3/2, you'd be right, but it's negative 3/2. Well, you could say 2.5. Oh, we'll keep it a fraction, though, 5/2.
What up, Matthews?
All right. Right-hand side, factors. X plus 2 is a quantity squared. All right. Now, the rest of it is just getting y alone. So let's...
Multiply by -2.
We could do that. Okay. So y minus 5 equals -2 times x plus 2 squared.
Oh, no, we don't.
In this case, it made it a lot nicer to work with. So that was a good move. The last step would be to do what? Add the 5. Next year you're going to learn a lot about how your first step and my first step don't necessarily have to be the same, and we can still end up with the correct final answer.
What I like about this is you don't actually have to solve it. You can just stop.
Yeah.
That's so nice.
Yeah, because then you don't have to worry about forgetting the plus or minus and simplifying radicals. There's a lot to it. Yeah, it's
So it's like
finding
H,
the bright
comma,
side.
K, right?
H comma K, so we need our vertex.
I actually got it right. I just got 2 comments.
My vertex would be what?
5, -2.
-2 and 5, because we're taking the opposite sign of the thing inside the
Oh,
parentheses.
I was so wrong.
And so my axis of symmetry,
-2.
x equals -2.
Are we going to do the activity explaining why we do something, or did the delay?
No, we're going to do it. I just got to figure out when I can
What was it
place
telling
it.
us? What is the thing that we're learning?
We are learning how the axis of symmetry comes from the roots.
So the axis of symmetry is always just the x value?
The x value of the vertex, yep.
Okay.
And again, folks, very important, don't forget the x equals. All right? And I don't like doing it, but you know that there's going to be the trick question on the multiple choice. I mentioned this yesterday. One of the choices is going to be a equals 2, negative 2. The other is going to be y equals negative 2. One of them is just going to be a negative 2, and the correct one will be x equals negative 2. So you don't want to fall for that.
But can that also mean the slope is negative 2? Is x
No, n is the slope.
Oh, there we go.
Right. I mean, a is also a way of representing slope. There's another linear equation model, y equals ax plus b. So in that case,
So that's the same thing, just with a different variable.
correct. Same concept, different variable.
So you could just put wx plus b.
Right. Yeah, you can redefine it any way you want. And sometimes folks will do that because if you have two different lines that you're comparing against one another,
You don't want to be mx and the other to be x.
right, just for lack, just to keep it clear, yeah. Okay, classes ago. All right, because here it's just asking us for the equation of the axis of symmetry and then create a table of values. And you know, it's easier said than done sometimes. You could use the completing the square approach for questions like these, but you could also use the axis of symmetry formula. All right, and that comes from, and we'll spend some time with this tomorrow. I'll show you where the axis of symmetry formula comes from, but it actually comes from the quadratic formula. So we start with that, and we can actually discover the axis of symmetry formula. It's pretty cool. But we know. Let me just pause. When we talked about axis of symmetry the first time, in your notes, I don't know what page it is, but it's prior to this one, obviously. We discussed the formula as being x equals negative b over 2a. All right, that's if you're working in the general form. All right, so the general form of a quadratic is y equals ax squared plus bx plus c. All right, so if you know that, then you can pull out your a, b, and c values. In this case, in the case of axis of symmetry, you don't need a c value because there's no c in the formula. All right, what's my b value? 0. The a value? 1. So our axis of symmetry, or a of s, is the equation x equals 0. All right, so if you're making a table out of this, you have x and y. You want 0 in the middle. All right, so negative 3, negative 2, negative 1, 0, 1, 2, 3 is usually what I do. They say, they said here at least 5 values. I go 7, typically. All right, so you could use your calculator as a resource for this, because if you put your information in, you know, you put your equation in and go to the table, looking at from negative 3 to 3, and that's another reason why I use 7 values, because that's typically, you know, with the older calculators, that's what they display. Oops, that's not clear. You can have it lined up so that you have your 7 values on display. All right, so you don't actually have to do the mental math to get those values, those numbers. So 7, 2, negative 1, and so on.
How do you get those if you don't use the calculator?
You got to plug these values into the original equation. So doable, but definitely takes some more time. For this one, not too bad, but obviously more complicated when you have a more complicated function. Okay, so then it's a matter of plotting these, but you have to be mindful of the fact that sometimes you have to scale your graph. Just take a look at your values and make sure that they're not going to be out of bounds. Okay, so negative 3, 7. Negative 2, 2. Negative 1, negative 1. 0, negative 2, and so on. All right, so there's your parabola. Once I put a curve through it. arrows on the end, because it is infinite, goes on forever. So if you don't put arrows on it, then you haven't done your job, so you lose credit there. All right, so just looking at the instructions, create a table of values of at least 5 points, vertex in the middle of the table, did that, then graph the equation. All right, and so they're all going to follow that structure. All right, so nothing different from that. So obviously some of the equations are a little kookier, but definitely doable in all cases. So the next page, let me select wisely here. Let me take number 5. All right, so write the equation of the axis of symmetry, create a table of values of at least 5 points. I personally like 7 points. It's the way I was taught. And also, I feel like the more points with parabolas, the more points that you have, the better sense of the shape of the graph you'll get. So it says at least 5. So that means 5 or more. So you can have as many as you want as long as you don't go any less than 5. Vertex has to be in the middle of the table. And then we graph the equation and state the roots of each equation. That's a typo. All right, they're not solutions because you haven't been given any parameters.
Can you typo that?
You can typo that, yeah. Points for someone.
The first person.
The first person.
Oh, I made one like a week ago and I literally forgot to do it.
Ah.
I can't remember.
Cole, B. Jackson, come on.
And they're off. Out of the gates. It's Cole coming up fast.
Oh.
Come on, Cole. Cole,
Jackson's coming down the back stretch. He's
Not now. It is not.
Cole's freaking out. It's possible he may choke under the pressure.
Doesn't say send. Why can't I send it? What is
I
happening?
can't
Oh,
send it either.
and Lexi comes out of nowhere to steal the title.
Send.
It wasn't letting me send. What happened?
Oh, she was like that girl that like took a train to like
I ruined it.
the city Boston Marathon and then won the Boston Marathon.
Oh, yeah.
Because she only ran like a quarter.
Yeah.
Wait, that's so smart.
Yeah, but it's also completely illegal.
And wrong.
Do you get money for winning? Yeah, but they figured out that she cheated and they took away the money.
Yes.
How does it make you
Because now all the bibs are electronic, so they can actually map your progress. But yeah, it's like, okay,
So messed up.
go, and then it's like, all right, swipe the Metro card, get on, or it's the T up there, or whatever.
Okay, well,
Not to win it.
All right, so we need our axis of symmetry. The axis of symmetry formula, if you don't need to go through the process of coming up with the standard form solution of a quadratic, it's just x equals negative b over 2a.
So you can just do that?
You can.
So we don't have to do this whole thing?
It depends on the instructions. Because sometimes the instructions will say, using the completing the square approach, in which case you're on the hook for that. But the axis of symmetry formula, which, like I said, we're gonna invent ourselves, probably Thursday, but I got to see how things shake out. It's x equals negative b over 2a.
Put that as like the program on the calculator.
You can. Very good.
that's probably why it's illegal.
And you like the prompt, right? That stuff.
Exactly. You're basically setting it up the same way you do the quadratic formula, just with that. So negative 6.
It's like the two equations for the quadratic because you can't do plus or minus.
Say it
You
again.
can't do plus or minus in the calculator. That's why we did the
That's why we do them separately. So we get x equals 3 as the axis of symmetry. All right. So the vertical line that I almost said cuts your parabola in half. Cuts your
parabola.
Cuts your parabola in half is x equals 3. So I want to build my table around this. So I'm going to create an x column and a y column. I'm going to put 3 smack dab in the middle. Like I said, I like 7 points. You might only want to do 5 points, but I'm going to dial it back 3 points in either direction, so 2, 1, 0, 4, 5, 6. All right.
Like 1, 2, 3, 4, 5, 6, fucking increasing order.
It's always in increasing order by integer values, but centered around whatever your axis of symmetry is.
Oh, your axis of symmetry can't be like the last number.
It can't be, you want it to be smack dab in the middle.
Math. Yeah.
Oh, that's why you have to do an odd number.
Yes, you can.
That
Right.
makes sense.
What's happening?
Let's say there's no middle of 6.
Oh, just hit zoom 6. That'll default it.
Perfect. What the heck is this?
So let's get our equation in. Y equals negative x squared plus 6x minus 9. All right, I'm going to go into my table, and I'm just going to align it with the values that I have here. So you may wonder why I like. You may wonder why I like 7 values.
Wait, isn't that backwards? Negative 1, 4, 9, 9.
Depends on what you mean by that.
That one's negative 9, 4, negative 1.
Right, it's symmetric, so out from center you're going to be given the same value.
5, 4, 3, 2, 1.
Yeah.
Can you do that again on the calculator?
Yeah, sure.
You just type in the equation for y equals and then do some graph.
And then you have to put in parentheses
So
or negative.
The original
So
equation.
why? Like, you know, like something like blank
Is
screen.
there another way to
No,
get
you
to
just
the
give me the
value?
equation. click
You
the
have to
seven
actually
values.
plug in each of those numbers for x and simplify. So it's doable, but not
Great, what'd you
I
say?
don't know.
especially if you get fractions.
No, nothing.
Oh, maybe pot 3.
And then second graph to get to your table.
Negative 9.
It's not letting me graph it. Like, I'll type in the thing and then it'll say error.
Okay, you see that plot 1 that's bolded? Hit the up arrow to get on that. Hit enter. And then hit down. Now type your equation and it's going to work.
Yeah, it's like the
I know, I lost my charger today.
All right, so we plot these points. We still have to answer the question that's being asked. Yeah. So 0, negative 9.
No, it does not.
Oh, that's unfortunate.
You just make another box.
Well, you can't. We have to live within the parameters of the graph, so that means we have to scale it. All right, so go by, what do you want? 2s, 4s, 20s?
746.
Go by 746s? I agree with that completely.
Yes, sir.
By 2s? Hmm.
Why do you have positive
But I can easily erase
Why do I have positive numbers?
It should be negative 1,
that.
negative 41.
Yeah.
That's a typo.
Oh,
I'm
I
taking a
just-
picture of that.
that doesn't count for crying out loud.
No, you actually put the positive.
Honestly, it was because I was too busy trying to help my students that I didn't notice the mistake.
Yeah.
No, I thought they were.
I appreciate that, you know, that's, in the end.
I mean, it is their fault, Eva's fault, because they didn't get far enough in the calculator
Yeah.
activity.
Yeah, I thought everyone was referring to that you put the blue numbers on the left side.
Oh, no, honestly, I was worried because I thought I screwed up putting the X values down. That would have been a problem.
I don't know if it's
But here, I think we're good. But thank you. No apologies. I had, it was about 15 years ago. I was teaching a statistics class at the college, and the problem, in order to solve it, it took 45 minutes. I made the tiniest of errors in the first step, like in the first 30 seconds of the problem. Nobody said a word. 45 minutes later, I was like, this is not the right answer. I just checked it. And one person, like, very smugly raised their hand. Well, that's because you made a mistake in step 1. And I was like, oh, and you only saw fit to mention this 45 minutes later. Okay, well, everybody, erase all your work. Now we have to do all of that again. And I had to keep the class half an hour late. in order to finish the problem.
Problems really take 30.
It's actually kind of nice though. It's just hard.
Well, that's the thing, but you would think that you could do that, but then your grade would not look as good.
You think that you could do what?
Just leave. Yeah. It wouldn't end well. So 0, -9, I'm going to plot that, but now notice I am scaling the y-axis, but I'm not scaling the x-axis. Is that a big deal?
No.
No, why is that okay? They both start at 0, and what do we assume if I don't put any labels on the x-axis?
It's going to be normal.
That's just going to be as usual. It's going to be normal, 1, 2, and so on. So it's only when you change the scale that we have to take notice. So 0, -9, 1, -4, 2, -1, 3, 0, 4, -1, 5, -4, and then 6, -9. All right. Now a root is defined as an x-intercept, so the point at which the graph crosses the or touches the x-axis. Doesn't always have to go through it. That's going to be right here. And so to define it specifically, we would say that the root is x such that x is equal to 3. We only want the x value.
Can you just write x equals 3?
You could. Correct. I mean, it's the fanciness component that's at play. Like how fancy do you want it? Now, let's take a look at this one on our calculators. And I'll show you some strategies. So zoom 6 is your standard zoom. Zoom number 6. You would think it would be zoom 1, because if it's standard, it should be like the first option that you see. Then hit enter, yeah. But if you hit zoom 6, it'll always bring you to a -10 to 10 window. And if you want something other than that, then you change the window. All right. Now, there's a few different ways. Ooh. Yeah, that's not even remotely.
What happened? Wait, bear with me.
Just double check your equation. And your y equals, you probably have the wrong answer.
Yeah, mine doesn't.
You're right.
Oh, you're missing the negative sign for the x squared.
Oh, that's okay. Now it's right.
How do you get x to like not equal like 0 or whatever? Because usually it's like defined already. So like when I
Oh, like in your home screen?
yeah no or like in the y equals.
Oh, it assumes it's a variable.
Really? Because when I did it,
I would die without this.
Yay! Goodbye.
yeah.
All right, so graphically, sometimes you want to find the roots, but you don't actually want to produce the graph on paper, right? You want to actually make a determination of where the x-intercepts are without having to go through all this. So I'm going to show you that in a sec, Kate. Oh.
Yeah, mine's up.
It's the same equation.
You have to pull up.
Wait, how do I get the...
Oh, you're plotting them. So enter on that. Those plots on the top.
No, it's not actually. And then scroll down the second graph.
The plots, if they're on, then it's.
That's the first one. That's the one.
Oh, plot 2.
Oh, but you know which one? Second graph. Second graph.
Excellent.
Wait, you're the 100. Scroll that up.
Okay. So, very important. This is a bailout strategy, not just for parabolas, but for any kind of function. All right. If you ever need to find the roots or the x-intercepts for a function, and it doesn't just have to be quadratics, it doesn't have to be lines. When we start talking about trig functions and log functions, it just more challenging functions. This technique's going to work also. All right. So what you're going to do is go into y equals. So this is to find the roots graphically on the TI. All right. So I'll just work off of that equation. You have y1 is equal to negative x squared plus 6x plus 9. Now I want to find where that equation is equal to 0, because that makes it a root. Say it again. I screwed up?
Yeah, it's mine.
It's nice, man.
It's minus 9, thank you. I want to find where the equation is equal to 0, so in y2, I'm going to type in y equals 0. There's other ways to do this, but this is the way that makes the most sense. Okay. So, as a second equation, I'm going to type in 0. So now I have two equations that I can look at the same time. Now, one of them is not going to really appear because it's going to overlay the x-axis. So when I hit graph, y equals 0 doesn't seem to show up, but that's only because it's directly on top of the x-axis. It's there, it's not obvious to us. Right? You draw a line on top of a line, it doesn't look like there's two lines there anymore. It looks like there's one, exactly. All right? So what we do then is hit second trace option 5, which is intersect. Oh, man.
But did you use like the internet?
No, I figured it out, but it was over a long period of time. So I learned one thing, mastered it, learned something else.
So that identifies the
Why
first
did you get
curve?
T84?
What's that?
That identifies the first curve.
Well, that's where we're going to start. So second trace 5, it asks you what is the first curve. At the top of your screen, you see y1 is the quadratic that we had in there. We're just confirming to the calculator that this is the first curve we wanted to look at. Because you could have like 5 or 6 curves in there. It's going to find the intersection between two of them. I have to tell it which two. So hit enter. Then hit enter a second time because y2 should be my second curve, which in this case is the line y equals 0.
So on a test,
It doesn't bring up second curve?
Mine is like y. Yeah,
It doesn't move.
Oh, it doesn't have to move. Oh, did you put y equals 0 in?
Oh.
Hit y equals?
Oh, for the second one, yeah.
Yeah, so let me take it from scratch here.
How do you get into the
So the y1 equation should be the original function. y2 should be 0. This is y2 equals 0. Go to the graph, hit second trace 5.
Okay, there we go.
Hit enter to verify that it's the first curve, right next to the graph. Hit enter to verify that it's the line y equals 0. Then it asks you for a guess, which doesn't seem very mathematical, but there's a rationale behind that. We'll talk about that down the line. All that's telling you to do is to get as close to the x-intercept as you can, and then hit enter a third time. All right. Now, what it'll do is it'll give you an approximation of what the roots are. So that's the calculator's approximation. It's based off an algorithm, a program that it uses to make this determination. So you have to interpret that. So this x equals 2.999999 and so on. That's the TI telling us that x is equal to 3. All right, and it's actually equal to 3. So if it's like that, if it was something like 4.999999, it's trying to tell you 5.
Oh, mine gave me
Why
3.
didn't you say 5?
Because it's based off an algorithm that once it gets close enough to the correct answer, it's programmed to stop at that point.
Mine gave me-
It is,
mine
but
gave me
it's a matter of
3.0000000.
processing. Right, so it is dependent on your
Is mine
guess.
wrong?
No, you're perfectly fine as long as you know that that's equal to 3.
Oh, we get 3.
Right.
Wait, what is the guess have anything to do with it?
That that actually is where the algorithm that's built into the calculator actually starts its computations. So depending on where it starts its computation, it spits out a different answer. So,
Purely calculator class.
yeah, I don't think anybody would take it though.
I would. But,
I appreciate that.
But now I know it's important. So like, you could do like sophomore year.
Yeah,
Maybe.
that's a possibility.
Did you be a teacher next year?
I don't think so.
Depends.
Well, I mean,
It depends on how well you
Yeah.
get.
I get it.
Exactly.
well, that's not what. Yeah, I wasn't going there with that. All right, so looking at number 1, again, axis of symmetry. It's a question of which method you want to use. Here, it's not specific. It didn't say using completing the square, so we can decide which way we want to go. Space-wise, it kind of makes sense to go with the axis of symmetry formula. X equals negative b over 2a. So negative what over 2 times what? What's my b value? Negative 3. What's my a value? 1. All right, so here we're looking at a positive 3 over a 2. So I'm going to make a table out of this, but I want to do it strategically. I said using, again, minimum of 5 values. Like I said, I like to go 7. 3/2 needs to go smack dab in the middle. Now, what I need are 3 values that are less than 3/2 and 3 values that are more than 3/2. If you want to go 2, that's fine. But I mean, if you want to do the bare minimum, that's fine too, I guess. But that also tells me a little something about you. What is the nearest whole number less than 3/2? 1. What about less than 1? Less than 0? Okay. Now going the other way. 2, 3, and 4. All right. So what I need now are the values associated with these entries in the x column. So I'm going to go into my y equals. I'm going to go into my table and you'll see that 3/2 is not there. All right. So I'll get what I can get from the table, and then we'll have to do something else to get the 3/2. All right. And that something else is not going to be figuring it out by hand because we don't want to do that. Negative 1 gives us a 6. Two, 0. 2 gives us 0. 3 gives a 2, and 4 gives us 6. So just do this real quick before I forget. So we have most of what we need. I just need the 3/2. So this is the way. I mean, it's a nifty trick. You don't have to do it this way, but again, it's becoming a recurring theme in this classroom where I show you a technique and you ignore it or you don't. So we'll see who listens. 3/2 not the cleanest number. I could type it in just the way I see it, or I could let the calculator do the work. So let me quit out of here and hit alpha trace. Alpha followed by the trace key. The trace is right next to graph. The first option is y1. Hit enter. It brings up y1. So now anything I do after this is going to rely on whatever is typed into y1. Open parentheses, type in 3/2. All right, this is function notation. All right, so what I'm doing, again, on my calculator, this is not the right pen, is I'm figuring out y of 3/2. So back to unit 4, when we talked about that useless function notation, f of x equals this, f of 2, f of whatever, where it had no purpose whatsoever. Why are we learning this? All right, well, y of 3/2, again, we get that by hitting alpha trace. Type in the 3/2. That's like saying f of 3/2. Hit enter, and it tells us what the result is. It will plug the 3/2 into your equation.
I got -1.
Okay.
I got 31.
I got error.
All right, well, start by checking to see if you typed the equation incorrectly. I got the wrong answer. I got the wrong answer also. So did I. So did I. So did I.
Yeah, mine, I have the same thing. I have the same thing as you.
Oh, I don't have
but I
anything
don't
typed
have
in that.
same answer.
What do we plug in here?
Oh, look.
All right, so now I have some points. Some of them I have to eyeball. But I didn't have to do the calculation. And so you may look at this and say, it's funny how that works out. So you look at the equation and say, oh, it's not too bad to do by hand, but just jazz it up to a more complicated equation. You don't have to do it by hand. You have a technique. Familiarize yourself with this. You can substitute numbers into any equation, no matter how complicated it is, using this technique. And now we all know. So this question is actually a really good indicator question because it gives me a sense of who really knows what the deal is, I guess. Because oftentimes what people will do with this particular question, and you know it's going to end up on the test. It's going to be there. They'll give me everything except for the 3/2, -1/4, and then graph this. They'll give it a little flat line on the bottom. All right, that's completely incorrect. That's not what a parabola looks like, so that could not possibly be the correct answer. If that ever happens to you, it's because you missed the vertex. You did not plot the vertex, all right, which means that you're missing the most important part of the graph. Now, in this question, they're also asking us for the roots. All right, so this is a root, and so is this. So we just have to identify those locations. So the roots,
1, 0.
we just need the x values. So x such that x is equal to 1 or 2. All right. The good news is you can get that information without plotting the graph because all you need to look at is your table. And within that table, if you can identify any location in which the y value is equal to 0, just think about any point that has a y value equal to 0. If a point has a y equal to 0, it must be on the x-axis. If it's on the x-axis, it's an x-intercept. X-intercepts, roots, they all mean the same thing.
If on a test it asks us to find the roots and we just write like 1 and 2 will points get taken off because it's not written exactly like.
Just don't use and.
Okay.
It's got to be or, but other forms of notation are fine. All right. So you can see there's little bits and pieces here that make it a little bit trickier if you're not really on the game. Right. So, but something like coming up with a -1/4, that should not be the hard part of this. All right, because the calculator is going to do that for you. Right. So you're looking for those little tricks of the trade, and honestly, I mean, you don't. I don't know how to say it without sounding a particular way, but like you're not getting this in other classes because they don't show this alpha trace stuff because they don't use the calculator that way, right? There's other strategies that they use. This is like I know the calculator so well that I can show you these inside little tricks that. other like math classes here at John Jay, Algebra 1, different teachers, they don't use the calculator this way. So, you know, and it's fine because they have other strategies that are really useful and valuable and stuff like that. They just don't do the calculator. They don't use the calculator the way I do, and that's there's nothing wrong with that. You know, and in a lot of ways it might even be better. But if you struggle with the calculation part of this, if you find that when you're going through a test, you get everything right, you know, in terms of the process, but then you screw up on like the simple calculation, this is your bailout. This will help you. So like looking at number 2, for example. Again, we have to do the x equals negative b over 2a. You can write a program for that, by the way. It's not too different from the quadratic formula program that we wrote together. You just have it compute negative b over 2a instead of having it compute the monster quadratic formula. So negative 2 over 2 times negative 1. What do we get there? 2 over 2, which is a 1. All right? So it's in that moment that you realize, okay, this is not going to be a difficult problem because I have a clean axis of symmetry. All right? Oh, possibly. Negative 1? Yeah. All right, so I just need to build my table around the negative 1. So I don't have to do the funky alpha trace in order to get these values. But I can show you really quickly. So let's say I wanted to really familiarize myself with alpha trace. I'm learning that today as a student. And you know, teachers in the front of the room telling me how important it is, how useful it is. I don't want to forget it, so maybe I do it this way. Maybe I do alpha trace for each one of these values. Alpha trace y1, type in the negative 4. Then do it again, alpha trace y1, type in the negative 3. and then keep going. Or you can go into the table, it doesn't matter. Okay? So just practice it in some way. It's really up to you. But if you center your table around your axis of symmetry, you can never go wrong. All right? So negative 5, 0, 3, 4, and then back the other way. Now, question, without even creating the graph, I know the roots based off of this table. What are those roots? See who's listening. Oh, 1, negative 3. Okay, I was expecting it the other way. Yeah, that's right. 1 and negative 3. Correct. Those are the ones that have the y values equal to 0. All right, so just by knowing which entries have y values equal to 0, you could identify the roots. All right, so I know it's going to be 1 and 1 or negative 3. No, that is not a marker. And visually, you can see where it crosses the x-axis. And that just kind of reinforces what we already knew. So we have a root here, a root here. So my roots, x such that x is equal to 1. What do we say, negative 1? Oh, negative 3 or 1. All right. So, you know, a lot of detail here, but generally, you know, it's probably overkill in terms of the amount of work that you need to show for, let's say, a multiple choice question. But if you familiarize yourself with the little details, then you're going to be better off for it. Because again, you know, we learn things a piece at a time on this level, but when you move forward, it all gets put together. And you know, if you're prepared, if you have those good foundations, it's never going to be a problem for you. All right, so you gotta put in the effort now, and you can't take your foot off the gas. All right, that's the key to everything. All right, so your homework